Good day, everyone. I am Beverly Lacambra, and I'm going to discuss the descriptive statistics for MCA 510. First, what is descriptive statistics? It is a brief descriptive coefficient that summarizes a given data set, which can either be a representation of the entire population or a sample of a population. It helps describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. With descriptive statistics, you are simply describing what is or what the data shows. Each descriptive statistics reduces a lot of data into a simpler summary. People use descriptive statistics to repurpose hard to understand quantitative insights across a large data set into bite-sized description. We have two commonly used measures of descriptive statistics. One is the measure of central tendency, and the other is measure of dispersion or variability. So what is measures of central tendency? It is a one-number summary of the data that typically describes the center of the data. It uses graphs, tables, and general discussions to help people understand the meaning of the analyzed data. It describes the center position of a distribution for a data set. So we have here the mean, the median, and the mode. Mean is the most commonly used measure of central tendency, also known as the average. Mean is defined as the ratio of the sum of all the observations in the data to the total number of observations. It is calculated by adding together all of the data and then dividing through by the total number of values. Next is median. Median is the middle score for a set of data that has been arranged in order of magnitude, the point which divides the entire data into two equal halves. One half of the data is less than the median, and the other half is greater than the same. Median is calculated by first arranging the data in either ascending or descending order. Last is mode. Mode is the most frequently occurring value. Mode is the number which has the maximum frequency in the entire dataset, or in other words, mode is the number that appears the maximum number of times. A data can have one or more than one mode. If there is only one number that appears maximum number of times, the data has one mode, and it is called unimodal. If there are two numbers that appear maximum number of times, the data has two modes, and it is called bimodal. And if there are more than two numbers that appear maximum number of times, it is called multimodal. So I have here examples. Our data. The girls' heights in inches are 62, 70, 60, 63, 66. To calculate the mean height, we need to add the data. So 62 plus 70 plus 60 plus 63 plus 65 equals 320. Now you take the sum and divide it by the total number of girls, which is 5. 320 by 5 is 64. So our mean or our average is 64. Next example, the girl's age is 21, 22, 24, 26, 27, 28, 29, 31, and 32. Since we have 11 data here, our median is 26, or our middle data is 26. But how to find the middle if you have an even set of data, excluding the number 32? Find the average of the two middle numbers, which is 26 and 27, add them together and divide by 2. So we have 26.5 as our median. Next example. Consider you have a data set with a retirement age of 10 people in whole years. So we have 55, 56, 57, 58, 59, and 60. Here in the table, the retirement age of 55 has a frequency of 3, 56 is 2, 57 is 1, 58 is 2, 59 and 60 has 1. So our mode is 55 years, 55 having the maximum number of frequency, which is 3. Next topic will be measures of dispersion. Measures of dispersion provide information about the spread of variables values. It tells the variation of the data from one another and gives a clear idea about the distribution of the data. It means the extent to which a numerical data is likely to vary about an average value. In other words, Dispersion helps to understand the distribution of the data. Classification of measures of dispersion. We have two, the absolute measure of dispersion and the relative measure of dispersion. The absolute measure of dispersion contains the same unit as the original dataset. It expresses scattering of observation in terms of distances, range, and quartile deviation. It helps to interpret the variability of data to know how much homogeneous or heterogeneous the data. Homogeneous means data are the same. Heterogeneous or data are different. Absolute measures of dispersion indicate the amount of variation in a set of values in terms of units of observation. Then the relative measure of dispersion, it is used to compare the distribution of two or more datasets. It compares values without units. Relative measures of dispersions are free from the units of measurements of the observations. There are fewer numbers. They are used to compare the variation in two or more sets which are having different units of measurements of observations. It is calculated as ratios or percentage. So we have here four common use measures of dispersion: standard deviation, variance, quartile, and range. The standard deviation is the most commonly used measure of dispersion. It measures of how spread out the data is. Standard deviation is the positive square root of the variance. Standard deviation is a measure. It is measure of how spread out the data. Its formula is simple. It is the square root of the variance for that data set. It is represented by the Greek symbol sigma. Next is variance. Variance is measured by how much data points differ from the mean. Variance is denoted by symbols here on the screen. Variance is the square of standard deviation for a given set of observation. Informally, variance estimates how far a set of numbers are spread out from their mean value. Next is quartile. Quartile is a set of values which has 3 points, dividing the dataset into 4 identical parts. The quartiles depict the distribution of dispersion of the dataset. As its name sounds, it is basically divides the data points into a dataset in 4 quarters on the number line. It is basically an extended version of the median. Median divides the data into 2 equal parts, which quartile divides it into 4 parts. Once we divide the data, the quartiles will be first quartile or the lower quartile, basically separate the lowest 25% of the data from the highest 75%. The second quartile or the middle quartile, also same as the median. It divides number into 2 equal parts. The third quartile or the upper quartile separate the highest 25% of the data from the lowest 75%. To get the better understanding of the quartile, we need to understand the median in a better way. A quartile is an extended version of that, and by dividing the dataset in 4 parts, it deals with the spread of values above and below the mean. Next is range. The difference between the largest and the smallest observation in the data. Range is simply the difference of the data of the largest and the smallest. The interquartile range is the difference between the values of the 75th percentile and the 25th percentile of the data. For better understanding, I have here the examples on how to calculate quartiles. First is line in ascending order and then divide them into quartiles. For example, we have here the data of shoe sizes 6, 7, 8, 9, 10, 11, and 12. So here is the formula for the lower quartile. N plus 1 times 1 over 4. So we have here 7 plus 1. 7 because we have 7 data. 6, 7, 8, 9, 10, 11, and 12. So 7 plus 1 times 1 over 4 is equal to 7. The middle quartile will be 9. The third quartile will be 11. So to get the IQR or the interquartile range, third quartile minus first quartile, and that is 11 minus 7 is equal to 4. So we need to get the fourth data, which is 9, 6, 1, 2, 3, 4, 9. This is our IQR. Next example, how to calculate variance and standard deviation. So this is our data, given data. Example in height in mm are 610, 450, 160, 420, and 310. First step, find the mean of the given data set. Calculate the average of a given set of values. So we need to get the mean. 610 plus 450 plus 160 plus 420 plus 310 divided by 5 because we have 5 data is equal to 390. So the mean average is 390 mm. The second step would be now subtract the mean from each value and square them. So we're going to arrive at the squared deviation. So 390. 610 minus 390 is 220. 450 minus 390 is 60. 160 minus 390 is negative 230. 420 minus 390 is 30. And 310 minus 390 is negative 80. After getting the result, we're going to square this data. So 220 squared is 48,400. 60 squared is 3,600. 230 squared is 52,900. 30 squared is 900. And 80 squared is 6,400. So we're going to divide it by 5 because we need to find the average of these squared values that will result in variance. So after dividing it in 5, we have the variance of 22,440. Now note that the square root of variance is standard deviation. So the square root of 22,440 is 149.67, and that is our standard deviation. Next topic is the group data and ungrouped data. In statistics, the term data is used to refer to information that has been collected and recorded for the purpose that has for projects, and it could be either qualitative or quantitative. Both group and ungrouped data are types of data. However, group data has been classified into categories based on similar characteristics, while the ungrouped data is raw data. So group data is organized into classes, and ungrouped data no forms of organization. Group data preferred when analyzing data, while ungrouped data is preferred when collecting data. Group data has higher accuracy levels when calculating mean and median, while the ungrouped data less accurate in determining the mean and the median. Frequency and tables are mostly used for group data, and lists are used in this data type for the ungrouped data. Group data summarize in frequency distribution, while the ungrouped data is no forms of summarization. I have here an example data for the group data. Examples 0 to 10, 11 to 20, and 21 to 30. For the ungrouped data, the example data are 5, 7, 10, 15, 21, 27, and 30. Both types of data can be used to calculate the mean, the mode, and the median of samples of population. Therefore, they are useful. Both types of data can be represented by frequency tables. However, for group data, there are no class limits. Thus, they are used to totally marks. For the group data in a frequency table has limits, and that is the upper class limit and the lower class limit. So that's it. This is the report for the descriptive statistics, and thank you for listening. I hope you understand the topic. Have a good day. Thank you very much.